Hello, everyone. Good afternoon or good morning, depends on where you are, and then welcome. My name is Qing. I'm part of the FluidTech Europe team, and today I'll be the motivator for this session. Soon I will introduce our speakers. There will be Lucas and Charlie Marino from the East Partnership, and today they will give us some insight into the criticality of corrosion and prevention. And here they are.
Hello.
Good morning.
How's everybody doing? Pops, Charlie Marino, corrosion expert extraordinaire. As you guys may be aware, we work together at East Partnership. And we were really excited to bring this topic to you because we haven't actually had a chance to present on corrosion outside of our normal DoD, DHS space in a while. So we wanted to bring you guys something a little different. And I wanted to tie the relationship between corrosion prevention, which is a problem for every one of us, and reliability engineering and lubrication together, right? Which is suitable and feasible for this application. So if you are somebody that owns physical assets, primarily those made of metals, this is going to be super critical to you. Good morning, Michelle. How are you? Love to see you here. And yeah, corrosion's huge. We come from a Coast Guard background, a naval engineering background. So we just eat, sleep, and breathe the world of corrosion prevention. But most people don't know that Pops, Charlie, he's like a corrosion expert, particularly in those fields. And so I thought it'd be really good to bring that level of knowledge into the presentation today, and show you that if you have a reliable piece of equipment, then you want it to be corrosion free. Just like if the inside of the equipment was degrading, then you would have concerns about that because you weren't using proper lubrication, or you were not operating the equipment in the proper context, or whatever the case may be. Anything that would degrade the operational readiness of the asset and take away from its ability to give you reliable performance, that takes away from something called operational availability, which is really, can I get what I need out of this equipment when I need it? Corrosion will stop you dead in your tracks if you don't keep it in check. It can literally cripple your physical assets, and obviously that will degrade reliability and availability. So we're going to get a little bit into the high level upper crusts of the science behind corrosion, just so you can understand that if you don't have a proper lubrication and corrosion prevention program coupled, you aren't really battling this problem. So I'm going to go ahead and shift into the presentation. Pop's going to take over as a subject matter expert, and off we go.
Good morning, everyone. As Lucas mentioned, my background is primarily marine application. I have the marine specialty through NACE. However, what we'll speak to today it applies to every industry, and the problem of corrosion is all around us. And so there's really nothing that we're going to discuss today that doesn't apply to many different industries. So I'm just going to cover, as Luke said, high level. We have to understand where corrosion comes from and then how to mitigate corrosion. You won't stop corrosion. It's the deterioration of a substance as soon as it is created or milled at a mill, and it starts to react with the environment. And so we'll concentrate on metals, primarily mild steel. However, everything, even wood, concrete, polymers, it doesn't matter. Some sort of corrosion, some level of corrosion happens with all different materials. So it starts from the oxide, iron oxide for steel. We formulate this different alloys to make different types of steel for different applications. And once it's exposed to the atmosphere, you may have seen it. If you took a brand new piece of steel and lay it out in your yard or in your shop, and any type of moisture gets to it, it flash rusts right away. You have some rust on that surface. That is the beginning of the corrosion process. We tend to get very used to seeing corrosion, right? When we come to our job for the first time, we're walking around the plant, we look around, we see small areas of corrosion, and no one seems to be concerned with that. And that is the problem, okay? Because these smaller levels, these smaller areas of corrosion will keep accelerating if they go unchecked. So it could be the destructive piece of it. You can end up with a pinhole size, a pin size hole in a tank. We're no longer retaining the liquid that is in that tank. It could be a casing of a piece of equipment. Now we're not keeping the lubricating oil where it belongs. Oftentimes our corrosion starts from the inside out, and we don't know it's happening until we have some kind of a breach in that enclosure.
So if that happens, is that because we don't have the proper type of lubricant or grease or whatever inside the machine?
It could very well be. And it could also be where perhaps this piece of machinery was laid up. We're not using it for a period of time. And so the normal bath it would receive of oil to prevent the corrosion cell from starting, because your oil acts as a barrier to the material, whatever that material may be, bronzes, brass, steel. It just depends on the piece of equipment. And so if it's not used for a while and we get moisture inside of that enclosure, that small amount of moisture can start a corrosion cell, especially when the protective barrier perhaps settles in the bottom of that sump or tank or whatever it may be. Fuel tanks are a great example of that on vessels. We don't paint fuel tanks because if the coating system fails, then we end up getting coatings in our strainers and our filters, and the machinery shuts down because you can't get fuel to them. So we don't paint them. And the normal movement of a ship keeps the fuel in the tank moving and basically coating that tank. So it really depends on the application.
And you won't get that in a solid structure on land.
You won't get that in a solid structure. So if you are laying up material, equipment, you need to make sure that you're laying it up properly. We do it with engines all the time, right? Mm-hmm. There may be a different coolant in an engine that has different properties while an engine's running and what that level of coolant is to what it is if you're laying that engine up for an extended period of time. Any equipment. So you have to understand your equipment. You have to know the equipment. You have to know what's internal to it and how to protect that, because you will not see it happening.
Right. Okay.
And what ends up happening is, so in a corrosion cell, there's four main components. There are electrochemical cells. It gets pretty involved. So we're just going to go, again, high level. For a corrosion cell to exist, you have to have an anode or negative, a cathode, a positive. Then you need a metallic path for that current flow. And in our machinery, that current path could be the machinery itself, that piece of steel, that piece of bronze, whatever it may be. And then we need an electrolyte. If you could remove any one of these four components, you remove the corrosion cell. That corrosion cell stops. So again, and the efficiency of that electrolyte increases depending on any impurities that are in it or what type of electrolyte it is. So any acids that have a spill, you have to clean that up because that's moisture with the acid already in that electrolyte.
Right.
Oftentimes, and that's a good example with an electrolyte that has acid in it. If you don't neutralize the acid, I found many problems where I went to look at places, and what they did is they cleaned it up, wipe it up with rags, take some water and they dilute that acid, but they also spread it on a larger area, and they still had corrosion because they didn't neutralize the problem of that.
They just spread the problem.
They just spread the problem.
Right. And you can't remove the equipment.
Can't remove the equipment.
Right.
You can't remove the metal,
Yeah.
right? Because it's the equipment itself, or the ship hull, or whatever it may be. It could be a steel deck in a factory, and you can't remove that. So really, the only thing you can remove safely is the electrolyte.
Gotcha.
Right. So you can remove the electrolyte. You can prevent moisture or minimize that.
Gotcha. To
understand the way the cell works, you have to understand the galvanic series. It's a pretty simple thing. But if you took a voltmeter and you went between an electrolyte and the hull of a ship, and you can, or a tank, if you look at the drawing on the lower left side, that is a silver oxide probe for vessels is lowered into the water, and you can actually read a voltage between that probe and the hull of the ship.
So there's something communicating between the metal of the ship and the ocean.
Correct.
And the ocean's the electrolyte.
The ocean is the electrolyte.
Right. And I can't remove the ocean.
You can't remove the ocean.
So removing the electrolyte's a hard thing.
Absolutely. And then, of course, you can't remove the hull of your ship either. Right. So what we're looking at here is, depending on your material in this galvanic series, you can see that there's a voltage value based on a reference cell. And so you have least active to most active. And if you look at the materials, you see you have gold, titanium in the more noble or cathodic positive range of that corrosion cell, all the way up to magnesium. And there's many different variants of these materials, right? Carbon steel is several different types of carbon steel, and same thing with aluminum alloys.
So the higher on the scale,
the higher on the scale, the more anodic or more negative, and they're going to give up electrons.
That just means that is going to corrode faster.
That's right.
Right. So if I'm looking at this scale and I'm thinking about the metals in my plant, and I see that a lot of my metals are at the top of this scale, I'm at a higher risk of corrosion.
That's right.
Just by the nature of the metal.
Or attaching two of these materials together without any isolation. And which is a type of corrosion we'll talk about.
Right. And that water around the ship in this example is an obvious example of one that's like pretty significant. But for like a landborne, it could be the material in the pipes.
That is correct.
It could be the air,
that is
right?
Correct.
The moisture
in the air.
And the electrolyte in the air.
That's correct.
Right. So you might not be thinking that the very environment you walk through has presented these hazards to you. And then the equipment you've selected, the way it was designed and built, introduces the other part of the equation.
Absolutely. Right down to the location of your plant, your factory, wherever it may be. Okay. So if you're in a salt air environment, it's a more efficient electrolyte. Right. If you're in a fresh, you're up on the Great Lakes area or you're inland, you're going to have less of that moisture.
And the other piece is electricity, right? All this equipment is energized.
That's correct.
Most of the equipment's energized.
So that gets into a whole different section of corrosion when you have voltage leaks to ground.
Right.
And such. Can we go back to one thing on the slide? Sorry. There is no influence outside of the actual material itself that causes this potential on the right-hand side of that scale. That's just the nature of the material.
Inherent.
And of course the different alloys will have a different value.
Right. So,
and we use zinc in this example is a steel hull, silver oxide, and you could see on the back on the transom of this vessel there is zinc anodes, and the zinc is high on the galvanic scale, so it's the sacrificial piece.
That's why we
use that in coolers.
Yeah,
in all industries, right? If there's water cooling, they'll put zincs in those coolers.
Gotcha.
Okay, so there are several different conditions that accelerate corrosion, oxygen being one of them, temperatures another. Depending where you are, when temperature goes up, the kinetic energy of increases in that material, and that movement of atoms and molecules will increase the rate of corrosion. And again, I'm just using seawater as an example, but for each 10-degree increase in temperature in seawater, you can double the corrosion rate.
That's crazy.
It is crazy.
So it's any water that has that balance.
Any water, and that's why you'll see if your business is in an area like on the islands. If you're on the islands down south, always warm, salt air environment, you have a higher rate of corrosion than if you're in an inland area with low humidity, and then you have a corrosion rate much slower.
Same with like plants on the coast of Middle Eastern countries.
Absolutely.
High salt content, even though it's a drier environment, they're using and in close proximity to the ocean.
Absolutely.
Or a bay or something that has all of these things present.
Yeah. And even in the using evaporators to make water in some places, many issues there as well.
Gotcha.
So sulfur dioxide is a problem, the gaseous product that most of us or a lot of us deal with. In a pure form, the absence of water, sulfur dioxide is minimum. Once we add, again, here comes the moisture piece of it. Once we add water vapor to that, the oxygen forms corrosive sulfuric acid. And so that brings us into pH. We start getting into the pH of any machinery. You should be monitoring that. You check if there's water coolers and such. So on a scale of pH is measured 1 to 14. 7 is neutral. 1 to 6 is considered acidic, and where 8 to 14 is alkaline. Alkaline doesn't become a real problem till like over. It depends on the material, but let's say 8. 8 to 9, because then it starts scaling.
Right. So I'm checking the pH of liquids to see if they're more or less corrosive based on whether they're acidic or alkaline, right? And I could introduce things like sulfur dioxide because I have combustion happening around me. Yeah. So this puts it in the air around my equipment. So engines, things like that.
Absolutely.
So we're constantly coating the equipment with things that are going to accelerate.
Right. And so barrier protection again, and I'm hesitating to talk about coatings because coatings often are the barrier protection. And I think in the case of this audience, much of it is lubrication. Yeah. This lubrication is also a protector and a barrier. So that brings us into, so any soot has some sort of corrosive components to it. And depending on the material, the substrate, which is the base material of the equipment or the tank or whatever it is that we're trying to protect, it could corrode at a different rate.
Gotcha.
Yeah. So moisture and humidity, keep it dry. So a couple of different types. I picked 3 or 4 types of corrosion that are prominent in most applications, and we'll cover those real quickly. So general or uniform corrosion, we see this. It's pretty much unsightly. It just needs to be blasted and coated properly for the first time, or whatever barrier protection is going to be put on it to prevent it from happening. You might see some like power poles along the highway that they're brand new power poles, and you go, oh my God, they're already corroding. Okay, that's a low carbon steel. Yeah, and they're malleable, but yet they're strong. And the difference is it's a low carbon steel. And so it forms an oxidation. So there's a difference between oxidizing and rusting. Right. Rusting is actually when you start to deteriorate the material, and only mild steel really runs red rust.
Yeah, the metal comes out.
Yeah, the metal just comes off in chunks. If we had time, I'd show you a whole bunch of examples. But in that low carbon steel, it's weathering steel. And it's like 0.03% low carbon steel. And it just, the outer layer oxidizes and it protects the rest of the steel. So it really depends on application. Okay, so we have localized corrosion as 2 types, pitting and crevice. And pitting is a crater type hole. They take on all different sizes. There are means to test the depth of that pit, but depending on the material, again, they can take these odd shapes within the grains of that material. So the lower left picture there shows you different shapes that a pit can take.
Gotcha.
Crevice corrosion is very similar to pitting corrosion. Down in the crevice or down in the pit becomes very anodic.
What does that mean?
The negative piece of the corrosion cell.
Okay.
And then the environment out external, any moisture on the external side plus oxygen makes it cathodic.
Gotcha. So you have all this happening in a little pit of metal.
So that little pit down in there, and the deeper it gets and the smaller it gets, the then that cathodic area seems very large as compared to it, and you accelerate the corrosion.
So it gets faster.
Right. So it gets faster.
So I always looked at this like cancer on ships.
It is cancer.
Because you can't really see it starting. And then by the time you realize you have a problem, you have a problem.
Yeah. So if you look at this picture here, you can see that.
Right.
This started out, these areas started as one pit.
Mm-hmm.
And then you have a breach, and that's a problem. And this is behind the frame. And these things, the pitting piece usually happens in places hard to inspect. So if you think about if I had to maintain that area, if I had to paint it, if I had to clean it, then lubricate it, if it's hard for you to get into to do that maintenance, that's where it's hiding.
Gotcha.
The easy stuff is easy.
Right.
Right. It's easy to paint. It's easy to coat. It's easy to lubricate. It's those areas behind framework, girders, underneath motor mounts, and that sort of
thing. And that goes to your last point there, which is like, you're going to have a problem because liquid corrosives get trapped in these spots you can't clean very easily or see, and they just starts the process. And then
there's very simple ways to take care of this.
Yeah.
We just don't have time to cover all that. And so that was, let me see, where were we? Localized crevice. And then we talked pitting. Now galvanic. Galvanic is becoming more and more of an issue because we want things lighter, we want things faster, and so we start going to lighter materials. And then in our minds we have that aluminum is corrosion resistant, right? I could take a hunk of aluminum, throw it outside on the beach with salt air, come back 10 years, and there's that piece of aluminum. I could do the same thing with stainless steel, but if I put those two together, we look at the galvanic scale, you can see that aluminum is way up here. Up in the least noble area, right? And stainless is down midway through that galvanic series. The further apart these materials are, the more rapid the corrosion rate will be for that anodic piece.
So for people that don't speak corrosion yet, what this means is you have two pieces of metal together. They have different
physically touching each other.
Yes, they're physically in contact. And they have different galvanic properties. Some are better or worse at preventing corrosion, and when you put them together, you actually change the relationship of that metal. The one that's inferior, the one that is more likely to corrode, takes the brunt of it, and it accelerates the corrosion on that piece because it's bearing all the burden.
So if you start having this failure, everybody runs to stainless steel hardware, no matter what they're putting together,
right?
And that could be okay, or that can be causing the issues. If it's a real dry environment and they're not too far apart on that galvanic scale, the rate will be super slow, and you may not have a problem for quite some time. If that environment is a moist environment and they are far apart, like stainless and aluminum are, you start to have these issues. The picture on the left, on the top, shows an antenna mount on an aluminum surface. This could be anywhere. It could be and that is made of stainless steel, and the hardware is stainless. All it would have taken to prevent that corrosion would put a piece of vinyl between it, a gasket that's a non-conductive gasket,
rubber?
So not a rubber works.
Just as long as it doesn't have wire in it.
As long as it doesn't have wire in it. Or as long as that wire doesn't touch both pieces,
right. Gotcha.
It's connected together.
Right.
So just look at it as a highway system, right? If there's a block at each end of it, you're good to go. You're in the middle. And then that's on the lower left picture, that is what's behind that stainless piece, because it was not separated.
Gotcha. And we're sitting on 8 minutes total left.
Okay. We have erosion corrosion. Many of you may have this in your piping systems. You start finding breaches in that piping system at weld joints around 90s, 45s. It generally doesn't happen in the straight run of pipe. It normally happens at those areas with more resistance. So depending on what is flowing through that pipe will determine that rate of corrosion within that pipe. Now, there's different pipe types to use for different materials, for fuel, seawater, freshwater, depends on what you have going through that pipe. But combined with cavitation areas and then that erosion area, you actually you start to limit over time that area for the fluid flow. So you may see different changes in your pressures and in your velocity, in the volume of liquid that you have. Again, depending on what's going through that pipe. If you're taking suction from the sea, as Luke had mentioned, no matter where you are to maybe cool things in your plant, you might look at and you start having a growth in your piping system, microbial. So you can make a little note of that corrosion and research that a little bit. So there's other types of corrosion that's well beyond the scope. Intergranular corrosion, that's where the grains of the material you start having issues. Exfoliation, corrosion cracking, stress corrosion cracking. It's a big deal.
Yeah.
Environmental cracking, corrosion fatigue. So you can have fatigue in a material, and then you can have accelerated fatigue because of corrosion. The combination of the two is a disaster.
Because you've weakened the metal.
Yeah, you weaken the structure. Bridges fall down because of that.
Right.
And tunnels failing, collapse, and the big issues with that.
I think the big thing about this is you can just see like even if you don't understand stress corrosion or environmental or corrosion fatigue, whatever, you can see that the last functional word here is cracking, fatigue, embrittlement.
Everything's a failure.
It's all a separation of material that's going to lead to
everything's a failure.
Yeah.
And you should know what that there's ways of measuring that material thickness. Again, I can go into that, but we don't have time. But and I tend to want to do that.
You're good. So what do we do about this?
So you need to know your equipment. You need to know your environment, because it gets right down to, you could be in a plant and you can have office space within that big warehouse area that's conditioned, and the outside area of that makeshift office space in the middle of this warehouse is not.
Right.
And so that temperature difference causes condensation on the outside. So if you're starting to see that type of corrosion around those types of areas, know that it's because of the environment we created.
Right.
Okay. So it's not only from nature, but also from what we create.
So select the right equipment and then maintain it properly. Use the right lubricants. Keep your coating systems intact.
Absolutely.
And don't use the wrong cleaning materials or introduce the wrong environmental elements.
So your safety data sheet and your product data sheet are really important. So anything you're using, you should have those sheets handy for yourself.
And we'll just bump through these real quick, guys, because I know we have like 2 minutes.
Yeah. So design, you have to know the design. Whether you're the designer or not, you have to understand the design so you know where to look.
Right.
That's the bottom line.
So get familiar with your equipment.
Remember, I said if it's hard to maintain and get in that space and to lubricate it or coat it, that's the areas you need to know in your design to look at.
Awesome.
So for coated surfaces, you have to be able to clean and prepare that surface. And there's a lot of steps in that process to apply a coating system. I'll just say this: if you're not willing to do the coating system correctly, you might as well not do it. You're going to be just putting money in the trash can.
Right.
You're just wasting your.
You're painting over cancer.
Yep. You're hiding things, and you may not be doing it, on purpose, but you really need to understand the reason for all of these different processes.
And by coatings, we generally mean paints for people that don't work in that world of work.
Absolutely.
What about uncoated surfaces?
Uncoated surfaces, again, everything's about clean and dry. If you could keep things clean and dry, then you'd be in great shape. Lubrication as a barrier to protect that surface from corroding is perfectly fine. There are actually spray applications for areas you can't quite reach and get in and do it. There's things that will repel water and give a surface that will, will protect that steel. Or correct grease, correct oil, spray lubricants, all of that will mitigate oxidation and corrosion, internal and external to machinery. So we don't just put any oil in something. We don't just put any type of a coolant additive in something to thinking you're protecting the water system or the oil system. Okay. Temperatures, don't forget, we have temperatures to be concerned about. So running machinery at the right temperature. Right. Anti-wear agents, all the lubricants. I'm speaking to the experts on lubricants. So all those different things. And we know when we're not doing the right thing. Oh yeah. Sometimes we don't have this, we'll use this. Well, you take this a risk. Yeah. That's a risk with that. Yeah. A proper coating system, and that means coatings as paint or coatings as a lubricant, a barrier, barrier protection. Grease has to be correct. The correct grease. Yep. You might think, you're using the correct grease, and it can have graphite, right? You can have things that actually cause corrosion of the base metal. Awesome.
Well, guys, this is us. If you need to reach out to us, you can find us here. You can find us on LinkedIn at East Partnership. You can find us on eastpartnership.org. And we'd love to talk to you. And if you just want to drop your name or anything in chat, I can reach out to you if you ever need anything. And that's pretty much the presentation, guys. Any question and answer you want to drop in the chat, we'd be happy to answer them for you.
That was great.
Yeah, you rolled. Yeah. Guys, we could have taken 4 hours to present this.
Yeah, just a 3-day course.
Yeah. So, All right. Yes, we tried. Thank you, Michelle.
Thank
Awesome.
you, Michelle. Hope to meet some of these folks in person sometime.
Oh, you're gonna love it.
Yeah.
We're most likely gonna be able to do that next month. We'll see.
Good.
If we're not in Canada.
Well, it must have been good. No questions.
No questions. That
So
means
we must have hit every nail on the head.
You're it. See, this is what happens when you bring an expert. If I had to give this presentation, they'd be asking all kinds of questions.
Hi, hello. Can you hear me?
Yes, ma'am.
Yes, ma'am.
Okay. Well, I just want you to know it's a very interesting topic. For me as well, it's very informative. I know the word of corrosion, but I have never thought through of that. I seen all those pictures like, wow, that, oh yes, I saw that. Oh, that's what it means. So, oh, this is great. I'm going to share with my husband. I felt like I know more than him.
Be sure to rub that in.
Yeah, tell them to get out there and start painting all those areas that are corroding.
Yes. Normally we just say, oh, the metal is rusted, and
Right.
you know that's the only thing we go. And sometimes when you screw something that has a piece of rubber in between, sometimes why would you do that? Oh, now finally I understand why. Wow,
Yep.
that's just wow. This is really great. Great. Thank you very much.
Thank you.
Yeah, like you guys
Yeah.
know, our time is almost finished. And then I'm really, for myself as well, thank you for your excellent presentation. And then, and also thanks to everybody who will join us. Indeed, like they have mentioned, if you have a question, you can drop at the chat or our platform to reach them. Okay. So we will say goodbye to everybody and wish you all a nice day still. Okay.
Thank you so
Bye.
much.
Thank you. Appreciate you.